Jai Hind everyone, myself Aastha Sharma from CSE department at Akgec Engineering College, and today I'm going to talking about what is the use of linear search in data structure and as well as the use of sorting in data structure. So basically what we are doing in data structure, we just going to organize the data in the form of with terms we using the structure. So for structuring the data, we will using some type of the like characteristics, like in data structure we will using the array, we will using the organize the data with the help of the linked list, we will using the organizing the data with the help of the stack as well as with the help of the queue, and now we will going to use the organize the data with the help of the sorting. So sorting, which means we need to organize the data in such a form, either it can be in the ascending order or it can be in the descending order, right? And in linear search and in binary search, what we will going to do in the linear search, the data, the whatever the data was present in the form of the any type of the data types, right? In linear search, what we are going to do is we just going to do to organize the data firstly, and then we find the midpoint, the starting point, and then we find the organize the data in a linear form. And in binary form, already the data is sorted and we need to just to justify the where is the data was present, right? So let's see the few tips, the few overview regarding the sortings, right? So basically the sorting, it is not another than it is the rearranging of the given array. So whatever the data was present in the form of the data types, we just need to what to do, we just need to rearrange the data. Either the data, it can be present in the integer form, either it can be present in the character form, or it can be present in the size form, or it can be present in a boolean form, right? So when this sorting provided some type of the library implementation in the C language, we going to use this. So in this sorting, there are numerous types of the sorting was present. The number one was present, it is a selection sort. In selection sort, what we are going to do, we just need to select that particular elements, and then we need to organize or to arrange the data at the particular position, right, in the form of the I comma j, right? Selection sort was there. Second sort was the insertion sort. Insertion sort, we just need to put the elements at the correct position of the data types, just like we are going to playing the cards, right? Next we have the sorting is the merge sort. Merge sort is based on the divide and conquer algorithm, right? So first we need to divide the elements, then we conquer one by one, conquering the elements, and after the sorting the elements, the left side and the right side, we're going to merge that elements, right? Next sorting is the quick sort. Quick sort is also based on the divide and conquer algorithm. In this we will using the pivot element to just to organize the data in the form, either it can be form of the left side and the right side, and then combining all the data in the ascending order, right? Next we have the bubble sort. Bubble sort is also type of the sort in which we are going to swapping the elements of the adjacent elements, right? Next we have the heap sort. Heap sort, it is the sorting which is fully based on the comparison based sorting technique, right? Bubble sort is also the comparison based, but it will be using in the adjacent element, right? Next, the technique is based on the binary heap sorting also, and it can organized optimization over the selection sort, right? So the algorithm is used in the form of the max heap. Suppose you have the numerous type of the elements. Suppose, let's see, there is the elements was there. This is the type of the elements you will be giving in the question paper, right? In this we need to implement the heap sort algorithm. What do you mean by heap sort algorithm? The elements can be presented in the tree-like structure, right? Tree-like structure, what do you mean? The tree-likes, we have the root elements as well as we have the left child and the right childs, right? We simply go with the flow of the making the binary form, right? Binary tree form. So the 81 was the root, right? Then left child we have 89, then 9, then 11, 14. Sequentially we will doing this, right? After making the heap, like in the form of the graph, trees form, then we need to heapify the element. What do you mean by the heapify the element? Heapify the elements, which means to rearranging the elements in the form of the max heap. How you can do with this? Swap the root elements of the heap elements and remove the last element of the heap after heapifying the elements and making the data in the linear form, right? Heapify the remaining elements and finally you will get the sorted array, right? Few important tips you need to remember while using the heap sort algorithm. Number one, like it is an in place algorithm. You don't need to go swapping or comparing the elements, right? Second is like implementation, it is not stable. It can be, it is the dynamic, it is not static, right? Next, the 2 to 3 times slower than. Why? Because every time you need to heapify the elements and then after sorting the elements in the linear form, you need to swap the elements. The first element can be swapping with the last element, right? So that's why it is slower than of the previous sorting. Like we have the quick sort. In this quick, we just using the pivot element to just sort all the elements, but in the heap sort, you just needed the first you need to heapify the elements. After heapifying, then you need to swapping the elements, root node to the last node of the elements. After that, you need to discard the sorted element and then again you go sequentially. It can be going again and again until you will get the sorted elements array, right? Next, talk about the advantage of the heap sort. Heap sort, it is the time efficient, time complexity, because it takes the larger time to compute and to solve the data, right? So heap sort is a time complexity. The time complexity, we have the O and log n, right? It makes the sorting algorithm on the basis of, we will be using the heap sort on the large data set. That's why it requires the more time to compute all the elements. Next, we have memory uses. Why memory uses? Because every time it needs to heapify the element and then swapping the element. Heapify the element, swapping the element. It takes, the process goes on, right, to sort the elements. So we will using this heapify functions to instead recursive one, right? Recursively, they call the elements and sort the element until it is sorted, right? Next, we have the disadvantage of the heap sort. Heap sort, we have number one, it is very costly. Why it is very costly? Because the constant times are higher than, because we have the complexity is n log n, right? Next, it is also the unstable. Firstly, it is disadvantage is very costly because because it gives the complexity of O and log n, right? Worst case. Next, it is the unstable. Why it is unstable? Because it's rearranged in the relative order. Now let's comes to the question and understand how it can be heapified and how the data can be arranged in the sequential order, right? So firstly, you will get this type of the questions in the question paper, right? You need to first make the heap. How you can make the heap? On the basis of the simple the graph we will made. The root elements, the left child, the right child, left child, right child, left child, right child. After making this, you need to make the max heap. Max heap, which means if it is require any swapping available, you need to swap this. So we will go from the downwards. Let's compare the elements because it is comparison based, right, approach. So we will compare in this 22 to 11. If there is any swapping available, then we will swap. If it is not, then we will move further to the element, because the 22 is larger element than the 11. So we will make the swapping available. It is swapped elements, right? After that, we have here the 89, right? 89 we having here. So 18, comparing the element 22 to 89, swapping available? No, it is not swapping available. Then next we will do 89 to 81. Is there swapping available? Yes, it's swapping available. We will swap this element. So on the left side of this element, what we called left side of the element is sorted. Then we will move to the right side of the element. The swapping is available? No, the swapping is not available. Next we will go to the right side of the elements, then left side. 76 to the 9, swapping available? Yes, swapping available. We will swap that elements, right? Then 54, because the 76 is larger than the 54, so no swapping is available. Then we will compare 76 to 89, swapping available? No, swapping is not available, right? So after making the heap to the heapify process, if there is any type of the swapping is available on the basis of the element is present, then you need to swap and sort the element in such a way, right? After making the max heap, you need to rearrange all the element in a linear form, right? So 89, 81, simply root left, right, root left, right, root left, right. The process goes on. 89, 81, 76, 22, 14, 9, 54 and 11. And the last step of the heap sort element is like you need to swap the two elements. What element? 89 is going to swap with the last element, right? So the element was 11, 81, 76, 22, 14, 9, 54, 89. So 89 is sorted. If in sorting, in heap sort, the element is sorted, it's discarded from the data, right? And then we will consider the remaining of element of the data. Then again we will make the heap. After making the heap, you need to heapify the element. After making the heapify, the max heap is formed. After the max heap is formed, then again the process is gone, and you need to do is the last element is going to swap with the first element is going to swap with the last element, right? In this we will in the first process we discarded the 89 elements, and in this we going to discard the 81 elements. The process is going on and on until you will get the sorted element. First you need to heapify the element in the form of the graphs, trees, right? Root, left and right. After making the heapify, you need to arrange the element in a linear order. And the last step of the heap sort is first element is going to swap with the last element, and the last element which is swapped with the first element, it is the sorted element, and it is not considered in the remaining of the data was present for making the max heap, right? Okay, this process again goes on. First, then 76 was discarded, 54 is discarded, 22 is also discarded. Then next is 14 discarded after heapifying this. The next is 7 and the last is 7. So you will get the, on the basis of the recursive algorithm, you will get the heap sorting elements, right? Next we will talking about the searching. What do you mean by searching? If I talked about, if I need to find out any type of, suppose you have the data set of the student database. In this we have the serial number, right? We have the name, we have the roll number. And if I want to find out any type of the name of the student is present in the class or not, what I'm going to do this, we're just calling the roll number. So on the basis of the roll number, I will find out the whole data was present in the table, right? So in this way we will using the data structure searching. So if you need to find out any type of the data, we will using the searching algorithm to search and find the data, it is present or not, right, on the database, right? So the searching algorithm, it is the type of the essential tool which will be using in the data structure to within the it is the type of the collection of the data set, and it is very efficient to navigate through while we using, and if you want to needed the any type of the desired information. So we will be using the searching algorithm. So in searching algorithm, there is a two type of the searching, right? The number one searching is the linear search, right? The number one two is the binary search. So let's talk about the linear search. Linear search, which means it is a sequential search. The present was the element was the data was present in a linear, in a sequential order, right? It is very simplest form of the algorithm, and it is also traverse the algorithm on the list of the element that was present in that. It is wisely used in the element to understand, and it has the complexity of ON. Right. Next, these steps, the steps which we'll be using in the linear search, the number one is, first you need to traverse the array. The number one condition in the linear search is you need to traverse the array until you will find out the element you needed to be searched, right? The process recursively goes and traversing the element one by one. Next, for each iteration for a loop, you need to find out that we have the element matches. If the element was matches, then it is simply discarded the process with the help of the base condition, and if it is not find it goes until the last element was present in the data set. Next, then move to the next element, right? Next, if there is no match, then there is we will consider it is then it considered to the return -1. right? How you can working in the linear search. So first, what we will need to do, see the working. First, we need to understand the linear search algorithm. Let's understand with the help of the example. So we will be taking the example in the form of the array, right? So you have this type of the data set was present in a linear order, right? In array, we indicate the each block with the help of the position, right? Indexes value. We also identified all the values with the help of the indexes value. So first, let's see. Let the element to be searched. For example, you need to search the element. This is 41. So how the linear search algorithm is implemented? First, it will goes to traverse the algorithm. Number one step is how it will traverse the algorithm. It goes to the 0 position of the elements. First, the computer will read the first element that was present in the data set, which is 70. And 70 is not equal to the 41. So which means the element is not matched. It goes further. Then it goes to the first element of the data set was present, that is 40, right? The element to be searched is k equal to the 41, right? 41 is not equal to the 40, which means the number is not matched. So again, it moves to the next element, goes to the second position, 30. 30 is equal to the 41? No. Then again, it is not matched, goes to the next position, 11, right? 11 is equal to the 41? No, it is not matched. See. It is not matched. It moves to the next elements. Then it moves to the next element, which is 57. 57 is equal to the 41? No. Again, it moves to the next position. So, at the fifth position, the element was present 41. So, which means 41 equal to 41, which means we find the matched elements. So, at this condition, the elements, the algorithm is stopped and the computer give you the message, the element is founded. Element is founded. And it will also give you the position, at which position it will find. The position is 5, array of 5, right? Next we have now the element to be searched, so the algorithm will return to the index value of the elements. Next we have the application where it can be implemented. It is implemented in the unsorted list and it also implemented in the small data set, because if you needed to find any type of the roll number or any type of the data was present in that type of the list, we will using in the small data set as well as we will using in the unsorted list. Next we have the advantage of the linear search. Then the first advantage, like it can be used in the irrespective of the whether the element is sorted or not. Secondly, it does not require any type of the additional memory, because it traverses the element on the basis of the elements was given to be the searched. Next, we have the disadvantage of the linear search. Disadvantage of the linear search, we have the complexity is ON, which means it makes the large data set and it is not suitable for the large array. As we already seen that it can be implemented on the small data set, so it cannot be implemented in the large data set. Now, we talked about the binary search, right? Linear search is very simple and it is mainly based on the comparison based, and in linear search we will do only the traversing the element until it is found or not, right? Element is to be found or not. Next we will be talking about the binary search. Binary search, it is a type of the search technique which is be using in a very efficient way the list of the elements in some of the binary form, which must ensure the data is to be sorted. So in binary search, the data which you will be giving is already sorted and you just need to implement the binary sort algorithm, right? So it follows divide and conquer the approach. Number one approach is right, it follows the divide and conquer approach, right? After the following, it divided into the two halves and each compared with the middle elements, right? Suppose in previously we have the elements to be find is 41. First, in binary search, it can sorted all the elements, right? After sorting, it can divide the element can be found in the left side or the right side on the basis of the divide and conquer algorithm. If it is found in the left side, then we will move to the left side and traverse the element, and if it is found, then it shows the answer, the elements to be found. If it is not, then goes to the right side, element is found or not, right? The process is recursively goes on until you will find the elements. Next, we have the working of the binary sort, right? So in the working of the binary sort, it can be taking the two methods. First, it will take the iterative approach. Second, it will take the recursive approach. Let's understand the recursive approach method, right? Suppose you will get the recursive method binary search follow on the divide and conquer. So here is the element which is already sorted, right? In binary searching, the element is already sorted. Suppose you need to find out k equal to 56. Right, the element is to be find k equal to 56. So first you need to find out the mid. How you can find the mid value according to this? So the mid value, the formula is beginning, right, beginning of the element, right, plus end of the element, this one beginning plus end divided by 2. You will find out the value. Beginning is 0, right, 0 plus 8 divided by 2, which means 8 divided by 2 equal to 4. So the value is mid is 4, which is 39. Okay. Next, after finding the mid value, then we will move to the value. The elements to be find out is 56, right? And 56 is lie on the right side of the element, right? So we will traverse one by one on the right side of the element because it is not present in the left side. So we will not touch the left side of the element. We will move to the right side, simply move on the left side. So the mid, why we using the mid values? To just making the process very fastly, right? So in this way we will using the divide and conquer algorithm. Now let's move one by one, traversing the algorithm. 39 move to the 40. Right, 31 is equal to the 56. No, it is not present. Move to the 40. 40 is equal to the 56. No, it is not. 51 is equal to the 56. No, it is not. Then 56 is equal to the 56. Yes, it is. And it is found the value, right? Then there are the few algorithm which is present in this. It will be using the divide and conquer algorithm, comparing the middle elements of the elements and finding the element to the process can be terminated after finding the element. Next, we have the application. It can be implemented in the building blocks of the more complex algorithm. It can be implemented, and secondly, it can be used in the computer graphics. Advantage of the binary search is it is faster than the linear, because in linear we just going to comparison based algorithm, while the binary search is used in the divide and conquer based, right? Next, more efficient for the searching algorithm. Next, the disadvantage like the array should be sorted, because if the array is not sorted, we cannot implement the binary search algorithm. Next, it requires the large data set being searched, right? So all these are talking, so all the previous what I am talking about the searching, which is the linear search and the binary search. Now let's talk about the hashing and the collision, right, resolution techniques used in the data structure. So hashing, it is a one of the type of the data structure which can be implemented to store and retrieve the data from the hashing table, right? Let's see, hashing involves the mapping of the data into the specific index, right? Index, it can be 0, 1, 2, 3, where it can be lies, right? So the great thing about the hashing is like in this we will using the search, insert and delete operation. On the time complexity we have the O1. Next, it is used to implement the data on the very keys and dictionaries. In dictionary, which is the Python, we will using this, right? Next, the hash table data structure overview. As you can see the structure of the data set. So the formula we will using like %10, right? %10, which means suppose this is the type of the list you will be giving in the questions, and after that you need to apply the hashing and collision algorithm, right, in this. So the formula in this we will using like hx, which is the hashing of the x, whatever the list was present. Next, equal to the list, the number of the list you will be taking in. Suppose you will be taking the 11, then 11 %10, what will be you get? 1. So the value of the 11 in the hashing table is listed in the first position, right? Similarly, you will do with the 12, 13, 14 and 15. So every time you need to do with the %10. So hx, right, which means x %10. Whatever the modulus we will get, so it can directly mapped on the hash table, right? So it is widely used in the data structure. O1 complexity was there, and it is also most popular in the array, linked list, and the self-balancing binary search tree. Now it is also used in the dictionary, and it can be using on the mainly basis for the data for accessing quick access the data with the help of the keys, right? Real world application is we will be using in the database indexing, cryptography, cache, and symbols tables, and the dictionary we will using the hash table, right? So there are the two forms of the hash, which is the number one is the hash set. Hash set it will be using in the Python also and the JavaScript to access the hash table values, right? Next, the situation where it can be where the hash is not used. The hash is not used mainly in the operation of the prefix search algorithm, where the strings and keys to be matched to be done. It can be used in the insert and the delete. It be using for the we need some type of the operations like the floor and the ceiling along with the search, and we will also use the self-balancing binary search tree. So the few components was needed to know about the hashing. The number one is the key. The key is anything that is string, any type of the data type which was present in the data structure. So we will mention with the help of the key, right? Next, we will using the hash function, which receives the input and the keys and the return the index value on the hash table. Next, we're having the hash table which is typically in a type of the array in the form of the list, which will be using in this, and it can implemented in such a way that corresponds the value in a associative manner, right? Here you can see the key is present in the form of the key 1, key 2, key 3, right? And the hash function is used to just to map the element on the basis of the formula, which is the x%10. After getting the value, you will map in the hash table, right? Next, how does hashing works? It works on the basis of the strings. It can be works on the basis of the any type of the data type, like integer, float, character, boolean, right? So let's take the example. One example is we will using with the strings. How you can map that element in onto the hashing table. So first we will assign like this in the array structure. So we will assign A is the 1, B is the 2, C is the 3, D is the 4, right? E is the 5, F is the 6, G is the 7. Similarly, you will add all these elements on the basis of the present was there, right? After elements, we just needed to mod the element. How you can mod the element? Mod with the 7. The last element is 7, right? So similarly, 3 mod with 7, 7 mod with 7, 18 mod with 7. The value will get 3, 0 and 4. 3, 0 and 4 are the number in the hash table. The 0 we will get the CD. In 3 you will get the 3AB value, and 4 you will get the EFG, right? Next, how the hash function can be used. So it is used for just to mapping the elements from the input key to the index value, right? And size you need to mention in the program, right? It is uniformly distributed in the form of the key. It also minimizes the collision. It also low load factor in the number of the items. So what is the collision in hashing? So basically 2 or more keys have the same value, and the collision makes if the value have same value a number of numerous times. So the collision was happen. So for this we need to consider the above of the hash function to map that value onto the hash table. So the collision does not happen. So this process goes recursively, right? The example we will taking on the string basis. Next, collision in hashing. The probability depends on the size of the algorithm you will be using to reduce the type of the hashing technique. Next, we will using the load factor in hashing. Load factor in hashing is defined as to the number of the items can be contained in the hash table, and the size can be mentioned on the basis of the load factor. So all these process. So today I have talked about the few topics. I talked about the heap sort. I talked about the linear and binary search. And lastly I have talked about the hashing and the searching techniques, hashing and collision techniques used in the data structure. All these topics are very much important on the basis of the AKTU processes and all, as well as the university processes. So next I will talk about the important questions regarding the university basis. Thank you.